What is denormalization? Denormalization is really normalization in reverse. However, I like to include a number of other things, namely data warehousing, which is effectively a database that's created for, amongst other things, reporting purposes. Data warehouses are generally a denormalized form of a live, active, or online client-server database to allow for faster access to information. Part of the process of creating data warehouse data and tables from an active database is a partial process of denormalization. Data warehousing is much more extensive than just denormalization, though. I like to put another subject area into denormalization as well. It's not really denormalization and it's not really normalization, and that is the area of separating different usage data. What do I mean by separating different usage data? What I mean is, for instance, taking highly active and highly inactive or historical data and separating those two types of data into different parts, different tables, different databases, whatever you like. Separation. For instance, if you had an accounting system and you've been using that accounting system and building up data for the last 5 years, and you really only want to look at the current month, what would be the point of writing select statements to read everything over 5 years when you only want to look at your active monthly figures? If your database was small, it wouldn't be a problem. If you had a couple of hundred gigabytes or terabytes, it would make a huge difference to the speed of queries. That's what denormalization is. It's really partially the opposite of normalization, but it also includes a few other more specialized areas. Why do we need denormalization? Why denormalize? Why take a complex, well broken down, divided up structure that lends to simplicity and effectively make it more complicated by taking data and sticking it back together again? The biggest problem with over-normalization is it causes performance problems. Normalization is really an academic thing. Denormalization is the commercial application of normalization. In other words, normalization is academic in that it goes way too far in breaking things down, and denormalization attempts to put things back together again. Denormalization will make your entities less complicated, and it will make your data more complicated, effectively, because you're going to have fewer entities, but you're going to have the data in one place rather than in multiple places. Normalization causes performance problems, so we denormalize to compensate for those performance problems. If you have fourth and fifth normal form, you have lots and lots of tables, you run a query against all those tables, you're doing effectively extremely complex multi-table joins. That is extremely slow. And it's also very difficult to tune SQL statements like that. A SQL statement with 15, 20, 30 tables in it is just impossible to make it run any faster without doing steps in between, which really what those steps are, effectively, are denormalization to some extent. Another reason to denormalize, which we've partially already mentioned, is an over-complex table structure. In some ways, a table structure with lots and lots of tables is very well broken down, and as you know, in terms of the object methodology, breaking things down into smaller parts actually creates simplicity, believe it or not, but it does. In a relational table structure, breaking things down too far in terms of normalization can actually cause problems. Remember, relational is not object, they're two totally different things. Denormalization actually takes a very granular table structure and makes it less granular. In other words, it creates fewer tables by sticking data together to make your SQL statements less complicated and thus faster. Again, complicated multiple table joins. Why denormalize? Because they're very slow. They can be very slow, they can be impossible to tune. They're just very difficult to deal with. Back to separating different usage data in terms of separating active data from large quantities of historical data. Reporting against application tables. Really, what this is actually the same thing as data warehousing. Your live online or client-server applications on a day-to-day basis are changing data, they're inserting, updating, deleting. If you go and run reports against those same tables, the two different aspects or applications are competing with each other. Your reporting application and your live client-server online applications are competing with each other for resources, machine resources, database resources. They're looking at the same data. You could have locking issues. The reporting tends to coagulate information. It denormalizes to read the information. So it tends to look at a lot of stuff at once, particularly when it's looking at application table structures. It can cause problems.